Okay, welcome to the first of my EG168 video lectures for semester 1 of 2012. What I'll be doing in these short online lectures is trying to answer some of your queries and clarify some things that we've already looked at in the main lectures, but having listened to some of the tweets that you've been tweeting in and your emails and chatting to you in the laboratory sessions, I've just tried to identify a few things that might not be 100% clear, and I'll try and clarify them in these short lectures. So first of all, recently we've been looking at the different ways in which MATLAB, the MATLAB computing environment, stores data. And one of the ways in which it stores data is in the form of a vector, and there are two types of vector that we looked at. The first one is the row vector, which is, so we might call a vector vec1, and we just have a string of numbers 1, 2, 3, 4, 5, written out in a row like this. So this is, we'd refer to this as a row vector. Whereas if we were to write a string of numbers in a column, and let's just use a random set of numbers here, 3, 6, 2, 1, 9. We would refer to this as being a column vector. So we also talked about the fact that vectors are simply one-dimensional arrays. So both a row vector and a column vector we would refer to as a one-dimensional array. We then moved on to look at the idea of a matrix as being a two-dimensional data structure. So let's create a matrix. We'll give it the name matrix. And whereas a vector is a one-dimensional array, a matrix, for our purposes, is we can think of it as a two-dimensional array or a two-dimensional structure of data. So we could put any numbers we want in here. And hopefully by now you are comfortable with how you create vectors and arrays within the MATLAB computing environment. Let's just put 1, 2, 3, 4 in the bottom row of this array. So we could think of this matrix here as being a 3 by 4 matrix. It has 3 rows in this direction and 4 columns in this direction. So we would refer to this as being a 3 by 4 matrix. We would also refer to this as being a two-dimensional array. We also explored the idea that an important property of arrays within a computing environment is that there is this unique correspondence between the index of an array and the value stored at that index. So for example, if we wanted to find out what the value was stored at index, let's say 3, 2 of matrix, so we might write this as the position at 3, 2 in matrix. Now remember, when we're listing the index of a two-dimensional matrix, the first number is the row number and the second number is the column number. So we would go to row 1, 2, 3 and then read across to column 1, 2, and we would take this value here. So the value stored at index 3, 2 of our matrix, which we've just called matrix, is equal to 2. So that relationship between the index of the array, which in this case is 3, 2, and the value stored in that array, which in this case is 2, is of critical importance. Now I've rewritten that matrix below, and there's a couple of ways that we can think about the data that's stored in this very simple 3x4 matrix. So of course we could just think of it as a set of 12 numbers arranged in a table, but we could also think of this as being a set of 4 column vectors. So we could think of this as being column vector 1, 2, 3, 1, column vector 2, 6, 4, 3, column vector 3, 1, 5, 3, and then column vector 4, 4, 9, 4. But we could equally think of this as being a set of 3 row vectors. So here's row vector 1, 2, 6, 1, 4, row vector 2, 3, 4, 5, 9, and row vector 3, 1, 2, 3, 4. And one of the things that you have to do in the second part of your MATLAB assignment is to first create a set of vectors and then use that set of vectors to create a matrix. You can always think of a matrix as being an assembly of vectors. So as you can see, just to emphasize that point, that we could, if we wanted, rewrite this 3x4 matrix as a set of 3 row vectors, or we could rewrite it as a set of 4 column vectors. Now within the MATLAB environment, if we actually wanted to compute, for example, if we wanted to actually input vector 1, which is a row vector with 4 elements within it, we could simply write, and we would type this into the command window. We would type in vec2 equals and then square brackets. We could either sorry, the first number would be 2. We could either just space separate the inputs or put a comma between them. So if we did 2, 6, 1, 4, if we just type that into MATLAB and press return, that would create this first element of the matrix here, a row vector. Or if we wanted to think of it in terms of column vectors and we wanted to create this vector here, I'll change the color. So if we wanted to create vector 1, we would do this by typing vec1 is equal to, and then the first number would be 2, and to turn this into a column vector we would need to use a semicolon. So if we did semicolon 3 semicolon 1, that would give us the column vector 2, 3, 1. Now one of the great things about MATLAB, which hopefully I keep stressing, is the built-in functionality within the computing environment. So for example, if we wanted to create a vector, let's write, for example, if we wanted to create a vector starting at 1 but going up in steps of 2, we could use this notation. So let's call it, we can call it Z. And what this would create is a vector that starts at 1 and then simply goes up in steps of 2 until it reached 10, but it won't go overstep 10, so the last number it would put in there is 9. So if we use this format, we would start at 1, we would increase in steps of 2 until we reach the value 10. A built-in MATLAB function that does a similar thing is the linspace function. So if we were to create the vector, let's call it y, and we wrote if we wrote linspace open bracket 2 comma 10 comma 5, this would create a vector for us that breaks up the space between 2 and 10 into 5 equally spaced numbers. So for example, this would start at 2 and step up 2, 4, 6, 8, 10, because we can split that gap between 2 and 10 into 5 equally spaced numbers, or linearly spaced numbers, which would just run 2, 4, 6, 8, 10. Now obviously when it comes to actually interacting with the MATLAB environment, the best way to do this is to open up MATLAB and play, so I'd encourage you to do that. And there's one final function that I want to make you aware of, because you will find it useful for completing certain parts of your assignment throughout the rest of this term, and that's the transpose function. And what this function does is it will convert a column vector into a row vector, or vice versa, a row vector into a column vector. Let me just quickly show you how this works. So if we've got a vector, we'll call it again vec1, and it's a row vector, 1, 2, 3, 4. And I now want to turn that into a column vector for whatever reason. And I want the column vector to be called vec2. There are two ways of doing this. We could explicitly write out the transpose function. So we could write transpose of vec1 in brackets, or there's a shorthand version where we could just simply write vec1 and then a little apostrophe. Both of these, if you type that into MATLAB, would give you that vec2 is now a column vector. 1, 2, 3, 4. Similarly, if we wanted to convert vec2 back into a row vector, we could use that transpose function again. So I hope that was useful. What I will do is, throughout the course of the rest of this term, in response to some of the feedback I'm getting to you via Twitter and via email and via the lectures and lab sessions, I will create a series of these short video lectures, hopefully to clarify some of your queries. Okay, thank you.